Hello everyone. In today's video, let us learn how to construct and test a 4:2 encoder. For ease of understanding, the video is split into two parts. Part 1 will contain the pin details of IC7432 and how to identify the pin numbers and fix the IC on the breadboard and then fulfill the objective of this video. At the end of this video, you will be able to construct and test a 4:2 encoder using OR gate. Let us collect the tools, equipment and materials required to do this practical. Digital trainer kit IC74LS32, connecting wires, magnifying lens. Let us discuss 4:2 encoder in simple terms. A 4:2 encoder is a digital circuit that performs the opposite function of a decoder. A 4:2 encoder is a digital circuit that takes 4 input lines and produces 2 output lines. The purpose of an encoder is to compress multiple inputs into a smaller number of outputs. In a 4:2 encoder, the 4 input lines represent a 4-bit binary number and the circuit activates a specific input line based on the binary input combination. It's commonly used in digital electronics for various applications such as data compression and signal encoding. Inputs and outputs. Inputs Y0, Y1, Y2, Y3. A 4:2 encoder has 4 input lines labeled Y0, Y1, Y2 and Y3. Outputs A1 and A0. The encoder has 2 output lines typically labeled A1 and A0. Let us discuss the pin details of IC74LS32. The IC74LS32 is a quad 2-input OR gate, meaning it contains 4 independent OR gates and each gate has 2 inputs A and B and a single output Y. The IC operates with a standard positive 5V DC power supply voltage and requires a ground connection. Each OR gate within the IC74LS32 has 2 input pins A and B. These input pins accept binary input signals. Each OR gate also has one output pin labeled as Y. The output pin produces the result of the OR operation on the input signals A and B. The output pin will be at a logic high if at least one of the input pins A or B is at a logic high. If both inputs are at a logic low, the output will be at a logic low. Here, pins 1 and 2 are input and pin 3 belongs to output. This forms an independent OR gate logic as shown in the pin diagram. In the same way, pins 4, 5, 6 form one independent OR gate. Pins 10, 9 and 8 form another independent OR gate logic and pins 13, 12 and 11 form another independent OR gate logic. Pins 7 and 14 are for ground and power supply respectively. Construction of 4:2 encoder circuit and verification of truth table. Collect all the components, check them and assemble the 4:2 encoder circuit. Identify the logic gates IC with their respective numbers. In this circuit, we are using only OR gate. This logic gate IC can be identified by their part number printed on the top of the IC. For OR gate, the part number is IC74LS32. Using the magnifying lens, identify the OR gate with its part number IC74LS32. Check that the IC has 14 pins with no missing pins like broken or damaged ones. Identify the pin 1 on the IC74LS32. This is usually indicated by a small notch on one end of the IC or a dot near pin 1. Begin counting pins counterclockwise from pin 1. This means that the next pin is pin 2, followed by pin 3 and so on. Place the IC on the breadboard. Position the IC over the breadboard so that pin 1 aligns with the notch or line on the breadboard. Carefully insert the IC into the breadboard, making sure each pin goes into a separate row of holes. Connect the input supply and ground to the IC. Pay attention to the specific pins that have special functions such as power supply, VCC and GND, inputs and outputs. Refer to the datasheet for a specific IC to understand the functions of each pin. From the pin details of IC74LS32, pin numbers 7 and 14 are allotted for ground and supply VCC. Connect pin 14 and the power supply point plus 5 volts using the wires, and connect pin 7 and the ground point using the wires. In this video, we have discussed the pin details of IC7432 and how to identify the pin numbers and fix the IC on the breadboard. See you in part 2. Thank you.